Let's look at the Pythagorean Theorem. This is probably one of the most used formulas and theorems in all of math that you will experience. So please make sure you understand it as we go through it. It is used with right triangles. A right triangle means that there is a 90-degree angle inside the triangle. We have three sides to a triangle. The two sides that are attached to the right angle are called the legs, and the slant across from it is called the hypotenuse. This is the slant. It is the side opposite the right angle, and it is always, always, always the longest side. So if you are given three values, you know that the largest value has to be the hypotenuse. The formula, a squared plus b squared equals c squared, where a and b are the legs and c is the hypotenuse. Same as saying leg squared plus leg squared equals slant squared. I'm telling you the hypotenuse is the largest number. So in your mind, be thinking about how you would add the two smaller numbers. Of course, they're squared, so not exactly. To find the hypotenuse, you take a squared plus b squared equals c squared. In my case, my legs are 9 and 12. Does not matter which is a and which is b. They are interchangeable. 9 squared plus 12 squared equals c squared. 81 plus 144 equals c squared. 225 equals c squared. The answer is not 225. 225 equals c squared. You want c. How are you going to find c? You're going to use a square root, the radical sign, so that the square root of each side, remember, whatever you do to one side, you do to the other. If I take the square root of 225, it equals the square root of c squared is c. c times c is c squared. So the square root is c by itself. You take the square root of each side and you get c. I give you calculator directions in case you're using the TI-30XA, which is what my class happens to use. 9x squared plus 12x squared equals, and then you must hit the radical sign, the square root sign. You notice I use those two words interchangeably. Square root and radical I use interchangeably. So using this formula, a squared plus b squared equals c squared, I can find any missing side. From what we know about algebra, we know that if you only have one missing value, you can use all the rest to calculate it. So let's say I only have one leg. So I only have b, or I only have a, so I'm looking for b. Subtract a squared from both sides, and I isolate b squared, which is what I was looking for, leg b. To find the hypotenuse, you add the legs together, but to find a missing leg, you subtract. So you are going to subtract the hypotenuse minus one of the legs. And everything is squared while you're doing this. So it's going to be hypotenuse squared minus leg squared will give me the missing leg. I'll isolate it. Keep in mind you are solving for a, b, and c, not a squared, b squared, or c squared. You will have to use the radical key before you get your final answer. To find a missing leg instead of the hypotenuse. Okay, I have here a right triangle. There is my right angle. My legs are 15 and b. My hypotenuse is 17. When you are missing a leg, you always start with the longest side, which is the hypotenuse, and you can subtract the leg you do have to find the leg you are missing. So another way to see it, a squared plus b squared equals c squared. I replaced a with 15 squared. I don't know b. I know the hypotenuse is 17, 17 squared. 225 plus b squared equals 289. Subtract 225 from both sides, and b squared equals 289 minus 225, which happens to be c squared minus a squared. So I took the hypotenuse minus the leg that I know to find the leg I'm missing. B squared equals 64, square root of both sides, b equals 8. So to find a hypotenuse, I add the legs squared. To find a leg, I take the hypotenuse and I subtract the leg I have squared to equal the leg I'm missing. If your answer is not a whole number, you're going to have to round. And if you don't tell anybody what to round to, you're going to use either the 10th or the 100th place. Use the 100th place. The 100th place is more precise. Precision in math is important. So here I had my two legs, 8 and 7. 8 squared plus 7 squared equals c squared. Notice that this triangle keeps changing, rotating. You need to be careful. You just need to know where the right angle is and that the legs are attached to it. So back to my formula. 8 squared, 64. 7 squared, 49, equals c squared, 113. Square root of both sides. The square root of 113 is 10.630184. It's going to go on. It's irrational. I say go to the 100th place value. Underline the 100th place value where I see that my underline got moved. Underline my 100th place value. Yep, it's not going to let me. Sorry. I'm just going to add a new line in here. If I underline my 100th place value, the 3, and I look to the right, then I will see that 0 says stay the same. 10.63 equals C. The Pythagorean theorem only works for right triangles. And if you have a right triangle, it works 100% of the time. This becomes a test to prove for right triangles. The Pythagorean theorem again. A quick review because normally I would do this over 2 days. You can use this Pythagorean theorem to find indirect measurement as well as the height of a pyramid or a cone, because you can make this invisible right triangle using the slant as the hypotenuse, the radius as a leg, and the height of your cone or pyramid as the second leg. And you can calculate either of the three numbers, the height, the radius, which will give you then the diameter, or the slant. You also can use it to find the distance between any two coordinates on a coordinate grid. You have any two plots, you connect them with a line, and then you put in your invisible right angle and create a right triangle. Using the length of the two legs, you can calculate the length of the slant. There's something called a Pythagorean triple. A Pythagorean triple is when you have three values that create a right triangle. You look at your three numbers and you can test for a right triangle. They love this question on standardized tests. To begin with, you have to have one number that's the largest. The other two can be the same as long as they aren't larger. So I have a 13 as my largest. That means it has to be C. So I plug it in for C. 5 and 12 go into A and B. It doesn't matter which leg is which. I do my calculations. If both sides equal each other, yes, this is a Pythagorean triple, and a triangle with these three lengths of sides will create a right triangle. Are 12, 15, and 20 the sides of a right triangle? Same thing. The largest one is 20. Put it in. Fill in 12 and 15 as your legs. I get 369 does not equal 400. Therefore, this is not a Pythagorean triple. Those three sides might create a triangle. There's another formula for that, but it won't be a right triangle. 355, is that a Pythagorean triple? No, it is not. The hypotenuse must have a longest side. In this case, the two are equal, the longest number. You cannot have two sides the same length. The hypotenuse must be greater. For all triangles, this is a nice little formula. For all triangles, the sum of any two sides of any triangle must be greater than the value of the third side. So if you are given three numbers, you can determine whether or not they will create a triangle. And if so, then you can do the Pythagorean theorem and tell me whether or not it's a right triangle. Again, another question asked often. They give you three numbers and say, will they create a triangle? Normally you just think, well, of course they will. They're three different lengths. Sure, that's not true. In this case, the sum of any two sides, 3 and 4, add them together. Is it greater than 5? Yes. 3 and 5, is it greater than 4? Yes. 4 and 5, is it greater than 3? Yes. All three work, so this is yes, a triangle. Now let's test if it's a right triangle. Longest side becomes C. 3 and 4 become the legs. I calculate each of the squares, and I get 25 equals 25. So yes, this is a right triangle besides. Here's some practice. 3 and plus 6, 9 is greater than 7. 3 plus 7, 10 is greater than 6. 6 plus 7, 13 is greater than 3. All three work. Yes, it is a triangle. Let's test for right triangle. I make 7 my C value. 3 and 6 are my legs. 9 plus 36 equals 49. But guess what? 45 does not equal 49. It is not a right triangle. It is a triangle, but it's some other type. No sides are the same. So aren't those usually called a scalene triangle? 3, 6, and 12. Let's practice. 3 plus 6, is it greater than 12? No, it's not. 3 plus 6 is 9, and 9 is not greater than 12. My very first test failed. I already know it is not a triangle at all. So therefore, it also can't be a right triangle because it's not even any type of triangle. There are 3 ways to do a Pythagorean proof that you will often do in a classroom. You can use graph paper where you do 3 squared plus 4 squared, and now you take those and you cut out all of the little pieces, count how many there are, place them together, and can you make 5 squared? Yes. You can also take all 3, cut them out, and can you create the right triangle? I have leg squared plus leg squared, so 3 squared plus 4 squared equals 5 squared. The length of that hypotenuse is the length of a 5 squared square. There is a third way, which is too complicated to do virtually like this, but there is a third way in order to rearrange all of the pieces and make your 5 by 5 squared. For now, I'm going to leave you with just the fact that the Pythagorean theorem is one of the strongest formulas ever. A squared plus B squared equals C squared, where A and B are the legs and C is the hypotenuse. Good luck.